For our tolerancing project, we decided to perform the GD&T for a ratchet screwdriver along with a flathead tool bit as shown here. While this may seem simple, ensuring a proper fit is crucial as the translation of forces is most effective if the part is toleranced correctly.
Here are two mating parts which have been simplified for our GD&T project. The female connector portion is a part of the screwdriver, while the male connector is the flathead tool bit. The faces along the hexagonal profile are the primary points of contact. If the profile were too small or too large, the forces would either be concentrated near the corners of the hexagonal profile, or the bit would not fit at all, and therefore there would be varying amounts of play that negatively affect the force output of the tool, thereby emphasizing the importance of proper GD&T.
For the female mating part of the screwdriver in which the tool bit will sit, there are specific areas to which we apply geometric tolerance controls to ensure proper fit between the two parts. First, we can look at the datums, which were chosen based on the surfaces that would be in contact with the tool bit. Note that we did consider that from a manufacturing standpoint, with all the other parts of the screwdriver in mind, that we may need additional or alternative datums to ensure that those parts fit together. But for our project, we focused on our mating surfaces for the sake of simplicity, and we decided on the following. Datum A and B are on two of the vertical faces that would be in contact with the male tool bit. These two eliminate a total of 5 degrees of freedom, only allowing translational movement along the cavity, which is then limited by datum C. To ensure a proper fit of the hexagonal portion of the tool end bit, we applied a profile of a surface control to a tolerance of 0.01 millimeters in reference to datum A and B. Note that we wanted to apply an uneven or unilateral tolerance zone to this control, but could not get it working in SOLIDWORKS. Therefore, we applied limit dimensioning for the parallel faces to enforce something like a maximum material control, in ensuring that the parallel dimension between faces in the hexagon remains at 6.6 millimeters and can only increase, not decrease. This should be reflected as well in the tolerancing of the bit.
For the male part of the tool bit, which will fit inside the screwdriver, there are specific areas to which we apply geometric tolerance controls to ensure a proper fit between the two parts. First, we look at the datums, which were modeled specifically with mating with the screwdriver in mind. Datum A and B are the two of the vertical faces that would be in contact with the female screwdriver. These two eliminate a total of 5 degrees of freedom, only allowing translational movement along the screwdriver cavity, which is then limited by datum C. To ensure a proper fit of the hexagonal portion of the tool bit, we applied a profile of the surface control to a tolerance of 0.01 millimeters in reference to datums A and B. Along with the limit dimensioning for the parallel faces, these two controls enforce something like a maximum material condition in ensuring that the parallel dimension between faces is the hexagon remains at 6.6 millimeters. Next, to ensure that the tool end of the tool bit is not manufactured skew, we added a parallelism control to this portion. By doing this, we will limit uneven wear on the tool and unwanted vibrations within the screwdriver cavity. Further, to ensure the verticality of the faces of the hexagonal cavity, we apply a perpendicularity control to the side walls in relation to datum C, as well as to the cylindrical bit between the two ends. This ensures that the faces of the tool bit will have as much surface area as possible to be in contact with the driving torques applied by the screwdriver. Lastly, to further limit play of the tool bit fit, we applied a flatness control to the end of the tool bit that gets inserted into the screwdriver where datum C is located.
The material finish on the screwdriver is a chrome vanadium steel, selected for its outstanding qualities. It delivers excellent durability, standing up to heavy use without wearing out, and it offers corrosion resistance to prevent rust and increase the tool's lifespan. Its high torque strength allows it to handle significant forces without bending or breaking, making it a dependable choice for challenging tasks. The tool bit features a black oxide finish, a high-performance coating designed to enhance durability and functionality. This finish is achieved through a chemical conversion process that creates a thin layer of magnetite on the surface of the tool bit. This layer improves corrosion resistance, reduces friction for smoother operation, and maintains the tool's electrical conductivity. With a thickness of just 0.5 to 1.5 microns, the coating ensures precision by preserving the tool's original dimensions, making it ideal for high-demand applications.